An object's motion can be described using its acceleration. Acceleration is considered non-uniform velocity. What does this mean? Non-uniform in this case just means not constant. An object moving with a constant velocity is considered to be undergoing uniform linear velocity. Since velocity is a vector quantity, it has a magnitude and a direction. An object moving with a constant velocity, then, is moving at a constant speed in a straight line. Both the speed and direction are remaining the same. In non-uniform velocity, the velocity of the object is changing. This could mean that the magnitude of the velocity is changing, as in the case of a car speeding up leaving a traffic light, or the direction of the object's motion could change, like a car turning at a constant speed. Or both the magnitude and direction could be changing in non-uniform velocity. Acceleration is defined as a change in velocity per unit time. Since the change in velocity is a vector, acceleration is also a vector. If our car moves with an initial velocity of v1 and a final velocity of v2, our delta v, or change in velocity, is equal to v2 minus v1. This means we can find the acceleration with v2 minus v1 divided by our time interval. We usually use the SI units of meters per second squared for acceleration. We don't really measure a squared second, though. The second squared means that if an object is accelerating 10 meters per second squared, then that after every second it is going 10 meters per second faster. Since acceleration is a change in velocity, speeding up is accelerating, turning is accelerating, and even slowing down is considered acceleration. If our car is slowing down, that means its initial velocity is greater than its final velocity. In this case, delta v, the change in velocity, would have a negative value, which means that the acceleration would have a negative value. We sometimes call this negative acceleration deceleration. Let's work an example problem. A hockey puck is sliding 17 meters per second to the left. After I hit it with a hockey stick, its velocity changes to 9 meters per second to the right in 0.4 seconds. What is the acceleration of the puck? Consider right to be the positive direction. First, let's draw a picture. We have the hockey puck first sliding to the left with an initial velocity v1. After it is hit, its velocity changes to a different value, v2, over a given amount of time. Also, the positive direction is to the right. Now, what information are we given? Our initial velocity, v1, has a magnitude of 17 meters per second. The positive direction is to the right, and our initial velocity vector is pointed to the left, so our initial velocity vector has a negative value, negative 17 meters per second. Our final velocity vector, v2, is 9 meters per second, and it's in the positive direction. And the time interval for the hockey puck to change from its initial velocity to its final velocity is 0.4 seconds. Next, what are we looking for? The acceleration of the puck. Next, we want to find an equation that contains our known values and our unknown value. We can use this equation, which gives the acceleration in terms of v1, v2, and delta t. Now we enter our values for v1, v2, and delta t into this equation. Finally, we solve the equation. Simplifying, we get 26 meters per second divided by 0.4 seconds, which comes to 65 meters per second squared. This means that after the puck was hit by the hockey stick, its velocity changed by 65 meters per second each second. We only looked at a time interval of 0.4 seconds though, so we only saw a change in velocity of 26 meters per second. I would recommend going through this method anytime you're working on a physics problem. First, draw a picture, then make a list of the known values you're given in the problem. Write down the unknowns you're looking for. Find an equation or equations that contain your knowns and unknowns. Enter your given values into the equations, and finally solve for your unknown values.